În deșertul Atacama din Chile se construiesc în prezent cele mai puternice telescoape optice din istoria omenirii, European Extremely Large Telescope și Giant Magellan Telescope. Aceste instrumente uriașe vor permite pentru prima dată studierea detaliată a planetelor asemănătoare Pământului și observarea primelor galaxii formate după Big Bang. Primele observații sunt așteptate în jurul anului 2028, iar intrarea completă în exploatare științifică este estimată pentru perioada 2029-2031. Pe vârful unui platou de 764 de metri din spectaculosul și aridul deșert Atacama din Chile se află o fereastră către universul nostru, telescopul gigant Magellan, finalizat doar în proporție de 40% și cu un cost de peste 2,5 miliarde de dolari. Acest telescop uriaș cu oglinda sa de 25,5 metri ar putea fi cea mai bună șansă a noastră de a găsi o planetă asemănătoare cu a noastră, numită exoplanetă, și poate chiar și spre viața asemănătoare cu a noastră. Dar acest vis ar putea fi la aproape un deceniu distanță. Între timp însă un consorțiu de țări, universități, oameni de știință și ingineri trebuie să finalizeze proiectul și să învețe cum să-l utilizeze în siguranță și să îl întrețină.
The surface of this mirror is so smooth that if we took this 27-foot mirror and then spread it out from coast to coast in the United States, east to west coast, the height of the tallest mountain on that mirror would be about half an inch. That's how smooth this mirror is.
The challenge with GMT is 6 of the 7 mirrors are portions of a parabola, but they're off the central axis. And in fact, the central axis is not only off-center in the mirror, it's way outside the mirror itself. So you have to work off-axis, asymmetrically, and yet put in this beautiful surface. We have to make this optic precise enough so that when the light travels 5-10 billion light years and comes and hits our telescope, we don't scramble and lose that information that's traveled so long.
Fiecare oglindă gigant cu care va fi dotat telescopul Magellan costă aproximativ 30 de milioane de dolari, situat la aproximativ 160 de kilometri de cel mai apropiat oraș și având în vedere climatul uscat al locației, telescopul gigant Magellan se poate bucura de 300 de nopți senine pe an. Când va fi pus în funcțiune undeva în anii 2030, acesta va avea cele mai bune șanse posibile de a detecta obiecte slab vizibile și de a-și îndeplini misiunea de a găsi în sfârșit acele mii de exoplanete asemănătoare Pământului care se rotesc relativ aproape de stelele lor natale.
Each of these mirrors, the glass alone is 20 tons of glass in each mirror. There are 7 of the mirrors. There's a mount made of steel that has to hold the mirrors, the structure, the instruments, the top end of the telescope where there are secondary mirrors. We have to measure the distance between the primary mirror and the secondary mirror to 1 part in 500 million. And then focus light to a fraction of a wavelength of light. It's an astounding, astonishing challenge. And this enclosure will be the height of a 22-story building. It's not an ordinary building. It has to rotate so that you can point the telescope in the sky and look out and see distant objects.
It has cranes, it lifts things, it has air conditioning, it has heating, it has power, it has liquid nitrogen, liquid helium. This is a complicated business, and it's a dance between the telescope and the dome that they all have to play together and work together to make sure the telescope delivers what it was built for.
So all of this elaborate structure that we have to build is really just to receive a small number of photons of light that are coming to us from distant space hit this small little patch where we've set up these mirrors and allow us to address these mysteries that we don't yet understand about our universe. It's like Ferdinand Magellan, after whom Giant Magellan Telescope is named. Here he was coming around Cape Horn. There was a whole other ocean there to be discovered. We don't know what's out there, but we're setting sail to try and discover what's out there.
We've learned in recent years, sort of the past couple of decades, that massive black holes are common, and in fact, almost every galaxy has a giant black hole at its center, and extraordinarily enough, there seems to be a roughly constant fraction of the galaxy's mass in the black hole. So we don't know, did the black hole come first and the galaxy grow around it? Did the galaxy build and the black hole formed after that? Where did all the stuff that went into the black hole come from? Did they grow by merging with other black holes, or did they simply feed, or they go through a gluttonous phase where they swallow stars whole to become so massive? Right now we can only see in any detail a few of those black holes, the ones that are either the nearest or the most massive. GMT, using the power of adaptive optics, will allow us to look at giant black holes almost anywhere in the cosmos, and will allow us to look at the small ones, the seed black holes, very nearby. As we try to track down the mystery objects, the strange beasts, the gamma ray bursters, the neutron stars, things that we haven't discovered yet that will go bump in the night because we don't have good time coverage, that's where we'll stumble upon these new discoveries.
Magellan este doar una dintre structurile masive aflate în proces de construcție în deșertul Atacama din Chile, cel mai mare telescop din lume dedicat observării lumii vizibile și infraroșii. Este însă telescopul gigant european, un proiect ambițios condus de Observatorul European de Sud, care promite să revoluționeze astronomia, oferind capacități de observare fără precedent. În curs de construcție pe muntele Cerro Armazones, situat în deșertul Atacama din Chile, este conceput pentru a obține imagini cu o rezoluție de neegalat, depășind cu mult capacitățile telescoapelor actuale. Programat să fie operațional până în 2028, acest telescop va permite descoperiri majore în domeniul astronomiei și cosmologiei.
This construction project is truly out of this world. In the middle of a desert, and on top of a mountain, the largest optical telescope on Earth is being assembled. It's almost the height of Big Ben, and when complete, it'll produce images of faraway planets that are 15 times sharper than NASA's Hubble Space Telescope.
This telescope will open the window towards part of our universe that today we don't even imagine.
An incredible 16 nations have come together to build something that would otherwise have been impossible. But how do you construct an extremely large telescope in one of the most remote locations on Earth? And how much will this really advance our understanding of the universe?
Space, the final frontier.
Stretching for around 1,000 kilometers along the Pacific coast of South America is Chile's Atacama Desert. It's the driest place on Earth outside of Antarctica. There are volcanoes, salt flats, and a whole lot of dust, features that kind of make it look like a scene from an alien planet. In fact, this is where the European Space Agency likes to test its Mars rovers. And it's here, 3,000 meters above sea level and 150 kilometers from the nearest city, that you'll find the site of an extraordinary project, one that's going to give humanity a better view of other worlds than we've ever had before. On this very spot, ESO, the European Southern Observatory, is building what they've cleverly called the Extremely Large Telescope, or ELT for short. Even with construction far from finished, you can easily see how it got that name. Because it's extremely large, and it needs to be to have enough space for the enormous mirror inside it. 39 meters long, it's 4 times bigger than ones found in the current largest telescopes of this kind. And it's actually just one of 5 mirrors that make up the whole thing, allowing it to gather 100 million times more light than the human eye.